In this lecture, we're going to be unwrapping a tree. As a matter of fact, we're going to spend the next couple of lectures working on this. The first part is mostly just talking about how I modeled this tree and some of the special features that I put into this to make the job both easier and more challenging for you. So this tree is a little bit special in that it was strategically designed for learning. In the real world, you might have trees that are even more challenging than this to unwrap, but you might use the same techniques to unwrap them. I'm going to break down all of that in this lecture, and then in the next lecture, I'm actually going to start unwrapping this. So it's important that you follow this lecture because I'm going to show you a couple of useful tips, and the next lecture as well. If I recommend that you watch this lecture and then download the tree and try unwrapping it yourself and see how you do, and then follow and then open up the next lecture after you've given it a shot to compare notes and see what you might have done wrong. Sometimes it's better to try first and then watch an explanation and then try again. So that's what I'm going to recommend for this. So there's a couple of special features about this tree. First of all, yes, I did design this tree. If you decide you want to use this for a game or some other project you're working on, you're welcome to do that. You have my full permission. So anything that I make in this course that I share with you, you're welcome to use in your own games or whatever. That's fine. So here's a couple of things that's kind of unique about this tree. When I designed it, I made all of the tips of all the branches hollow. So if I zoom in very far, you can see there's actually a hollow tip on the end of this. This is going to make it easier for you to unwrap this if the tip was already hollow. Now, in the real world, you might be using a tree where the tip actually came to a vertex point. Let me give you an example of that real quick. So I'm going to scale this down to 0 and then remove doubles. You can see it removed 11 vertices. It's 11 because there's 12 vertices around the shape of the cylinder, and it got rid of 11 out of 12, leaving only one vertex behind. And it's that vertex right there. So let's imagine that all of your branches ended with a cone shape like this, with a single vertex at the end. I want to show you real quick how you could go about fixing this to have an open end, or as I like to say, a hollow point. It's not that hard if you use Blender's tools, specifically its snapping tools. So assuming that I want to keep the same rotation, the same scale, and I want the tip of the cone to be exactly the same location, this is how I would go about doing this. Let's use edge selection and select this loop, and then extrude it out like this. And I'm just going to rotate around and just grab this and kind of line it up. I'm eyeballing it right now, but just kind of get it close to the edge. This is one way to do it. You could eyeball it like this, but you don't really need to eyeball it. So if I had extruded this out like this, even if it's really far from the end, I can use Blender snapping to snap it exactly into place. So the tool that I want to use is snap selection to cursor offset. However, I need to move the cursor first because currently the cursor is somewhere else. It's in the middle of the world space over here. I want the cursor to actually be right here. And then that way I can snap this to the cursor. With this selected, the end of this cone, let's go to snap cursor to selected. That puts the red and white cursor in the middle of that vertex. Now I can go back over here, select this loop, and do just the opposite. This time I'm going to snap the selection to the cursor. There's two versions here. We have selection to cursor, and we have selection to cursor offset. The one we want is offset because we have more than one vertex selected, and it's formed some kind of shape, and we want to maintain that shape. So we're going to use this option here. So you can see it snaps over there, and it's not eyeballed. It's perfectly centered on that 3D cursor, wherever that cursor is. So that's great. This is now exactly in the place that we want. Let me show you something by undoing. I'll show you what would happen if we had chosen the one without the offset. So selection to cursor, you're going to see all 12 of those vertices collapse into a single point, and they're all going to be centered on that one vertex. That's not what we want. So it would look like this, and it would just bring us right back where we started. So instead of doing that, we're going to do one last time, selection to cursor, offset. Once that's done, we can actually delete the cone. The quickest way to do that is to select the vertex at the end of the cone and just delete that vertex. That leaves behind this new cylinder that we just made. You'll notice that the problem with this cylinder is it's actually inside out. I'm looking at the outside faces right now. This is one of the outside faces, and I can see through it because I have my back face culling on. But you'll notice that the inside faces I cannot see through. So that means that all these faces are inverted. They're flipped normals. So I'm just going to select all these faces. Probably a good idea to select them one at a time. And the reason why is because in some cases there might be more than a face or two, or maybe a couple of faces that where the normals are not flipped, and so you would not want to select those. But just take a look around and make sure that all the stuff that you have flipped are stuff that actually needs to be flipped. So take a look around. If it looks right, then just go to Control F, flip normals. Now it's all going in the right direction. Finally, you're going to want to edge select the loop and scale it to 0.1, which is it's close to 0. And that's it. That's how you would convert a cone to a cylinder and maintain the shape, the rotation, and the size and everything. Okay, we spent a lot of time on that. I want to show you a couple of more things. First of all, what I'm going to be showing you right now is how the branch connects to the trunk, or how these smaller branches connect to the larger branches. So this right here is the base of the branch, and then it extends out until it gets to the very tip of the branch. What we want to do while we're unwrapping this is we want to outline the base of the branch. So I'm going to have to show you how to recognize what's the base and what are just random lines. So we're going to be focusing on just this much of the geometry at a time. So what we want to do is recognize the base. So as you can see, this is the thicker branch, or the trunk, and this is the thinner branch. And this right here, which is made up of triangles, is basically the junction, or the part where these two branches split apart. What we're looking for is the base. So we're looking for something like this. And this is the area where the branch and the trunk intersect with one another. And that's basically what we're going to be covering in the next lecture. So I just kind of wanted to show you with this shape. Now, the way that I designed this tree is kind of interesting. I modeled this thing from this shape right here, and then I copied it. It had geometry like this, and I basically duplicated it, brought it off to the side, rotated it, scaled it down a lot, and lined it up kind of like this, and basically erased part of the geometry of this piece over here like this. So I deleted those faces, and then I basically bridged these together by creating a series of triangle shapes. Technically I created quads, and then I converted them to triangles to make it look more rounded, but something like that. So if you can visualize this turned into this, and then later, with enough of that work, something like this. So you can see here's one branch, here's another branch coming off of that one, here's another branch coming off of that one, there's a branch coming over here, so on and so forth. With enough iterations of that, this ends up looking like a tree. So that's how it was made. So it's important that you understand that for the next lecture. And then other than that, really the only other thing that's special about this and what makes it a good practice piece is I actually hid a couple of flipped normals somewhere within the geometry of this object. I'm not going to tell you where, because I think if you find it on your own, it'll be a better exercise for you. So this will be the first time in this course that I actually have you searching for flip normals that I hid like Easter eggs inside of an object. You're going to run into these problems in your own projects, and you're not going to know where they are. Nobody's going to tell you where they are. So this is a fantastic exercise. So with that said, let's move on to the next lecture where we're actually ready to start unwrapping this tree. So go in there and give it a shot, and when you're done, come back, and I'll meet you in the next lecture.